In 1956, Hodgkin and Keynes made a micro-injector which could be inserted down the axon in the same way as the simple electrode. During tests, repeated here by Professor Keynes, the fine glass capillary contained a column of dye a few millimeters long. The syringe was mounted so that during injection, the barrel moved over the stationary plunger. Thus the capillary withdraws, leaving the injected solution behind. Of course, during an experiment, the solution was colorless, so its limits were marked by two small bubbles. But the micro-injection technique could only add substances to the axoplasm. There was no opportunity of removing them. In 1961, Baker, Hodgkin and Shaw succeeded in doing just this. In this short sequence, made at the time, Professor Shaw shows how, with a device rather like a miniature garden roller, the axoplasm was gradually squeezed out. An uncleaned axon was used so that the small fibers surrounding it would give the membrane some protection. It was then possible to re-inflate the axon by forcing an artificial solution through it, using, in these early experiments, an old gramophone motor connected through gears to a caliper syringe. During the rolling out process, some of the axoplasm is forced back up into the tip of the cannula. As the pressure builds up, this is forced out of the cannula and travels down the length of the axon as a small plug, until finally ejected. The lumen of the axon is now completely clear, and solutions flow through it with ease. Previously, such an isolated membrane was thought to be completely dead. However, the striking fact was that this supposedly lifeless tissue still displayed all the essential behavior of a living nerve. It could still conduct up to 500,000 impulses, even though large volumes